Dear students, welcome to fourth lecture of this course. In this lecture, I am going to discuss geometric modeling. Let us first define the geometric model. It refers to computer compatible mathematical representation of geometry. So in this definition, I would like to stress two keywords. One is compatibility with computer or computer compatible, and the second one is mathematical representation. Both of these are very important. You can recall that you can always define a line with the help of some equation, mathematical representation. But the way you save it or store it in the computer in such a way that you can access the information again and again for various applications, manipulations, for example, extending the line, etc. That is very important. So that is what is provided by or facilitated by the geometric model. And it deals with the geometric model deals with the representation of curves, surfaces, and solids, because the curves and surfaces, they are the constituting parts of solid. So every solid, it will have some kind of surfaces to define it, as well as any surface will have some curves to define it. So the second thing is, it is the basis for creating, representing, manipulation, and storage of designs in today's CAD system, whether you are using SolidWorks, Fusion 360, NX, or Solid Edge. All these software, they make use of the CAD model or the geometric model. Geometric model also forms the basis for integrating design with other life cycle activities such as manufacturing. I think this will be more clear. The integration of the geometric model with other life cycle issues will be more clear with this slide. You have earlier seen various examples of applications of CAD/CAM software. So those applications are not feasible without the help of a geometric model, or without geometric model data or geometric model information being the central part of it. So in this figure, you can see that the geometric model is forming the core of this all the applications, and based on that, all the CAD/CAM applications work, or they have access to that database, which is a geometric model. These are the types of geometric models. Three types of geometric models are basically used. One is a wireframe, then you have the surface models, and then you have the solid models. So all the software, they facilitate you to have the any of these kinds of geometric models. When we talk of the wireframe model, this you are representing a solid with the help of its defining edges. For example, this part is being defined with the help of its edges, all the edges. And in this wireframe, you have typically three variants. One is when you are showing the hidden lines with the dotted lines, hidden lines with dotted lines. And here you are showing the hidden lines with thick lines. Okay. And the third one, you have the wireframe model, where the hidden lines are not displayed. So all these three kinds of variants are available in your CAD software. Then you have the surface model. So surface models are used when you are having there is importance of the surface you are going to generate. For example, in this case of a mouse, the surface of this mouse is important because you are going to contour it in such a way that it gives you a kind of comfort when you are touching it. Okay, when you are using it. So based on this surface model, you are generating the model of the mouse. You are adding other materials and all that, other features which are functionally important but not important from the its usability or the is interaction with the hand is concerned. The second example of the surface model is a car body panel. For example, there's the contours of this car body panel. They are very important for aesthetic and saleability point of view. So that is why the surface model of this kind of features of the car, okay, they are done first. They are made first, and they are further used to develop the full model of the CAD model of the car. And the other kind of solid model, CAD model or the geometric model is the solid model. So in this, as you can see, you have all the details of all the features. Well, this includes all the surfaces and edges as well as the information about the material. So in surface model, you don't have any thickness of any surface, but you add on the thickness after you make the surface. So that is the only difference in solid model. You create the solid directly so that the material information is contained in it. Another important aspect that I would like to use the coordinate system. Uh, you can refer to this geometric model. In this, it is a basically a six-sided polygon, 1 2 3 4 5 6. Okay, so this is first extruded in this direction to have this one solid, and on the top of it you are having a hole, cylindrical hole like this, and then you have a rectangular hole. Okay, so how you are doing this, how you are making this is this hole basically is to refer to this surface patch of this model after you generate it, and on the top of that you are generating this sketch, rectangular sketch, and this rectangular sketch is actually made with the help of two reference surfaces, edges, this one and this one, so that you can properly locate this sketch and then extrude it or make a extrude cut. Similarly, this one is referred with respect to say this line and this line, okay, to locate this. So what we do basically is every geometric model will have a common references, just like this one. So this is a 0 0 0 with respect to this. All the features or entities of this part are referenced. And here, when you are generating this sketch, you are temporarily referring to this edge and this edge so that you can properly locate this. So this is nothing but called a working coordinate system, which is used for creating the geometric model. And once it is created, the information is not important, okay, unless otherwise you want to edit it in the same. Now once you are working on this surface, you want to interact it, or you can interact it through the system and with the help of the screen. So you need to convert this surface information and correlate it with the screen coordinate system, where the information is in the form of pixels. Okay, so you have say 764 pixels on this side, sorry, on this side, and 1028 on this side. For I'm just giving you example. Okay, so you pick some point and that point is correlated with this point. Okay, so this is known as a screen coordinate system. This is hardware dependent, and this is dependent upon the model, the geometric model information. Okay. Now, this slide will show the interrelationship between these three coordinate system, which are important for geometric modeling: model coordinate system, working coordinate system, and screen coordinate system. And the last thing which I want to discuss here is the solid modeling techniques, although the details of which we'll be discussing in a separate chapter, because we'll be discussing the solid modeling. There is a complete lecture on this. And basically, we have five kinds of solid modeling techniques. The first two are the constructive solid geometry, which if you have used AutoCAD, so they provide you a user toolbar where you have the models like cuboid, sphere, okay, and other things, primitives. So you can use all these primitives to construct your solid. The second kind of feature modeling technique is the feature-based modeling. So if you have used SolidWorks or NX or Fusion 360, they provide you the features like extrude, cut, hole, etc. So these are the predefined features, and you have a feature library which you can see on the panel of the software. And with the help of these software, you will construct the solid. So these two are basically the techniques for constructing the solid. And there is another technique which is the boundary representation. Boundary representation is once you have constructed the solid, you want to represent it, because there are maybe variety of ways you are constructing a solid, but boundary representation will represent the final geometry, okay, of the solid with the help of the containing surfaces basically. And then you have the spatial enumeration techniques, like you divide the space of the solid into different units, okay, small units. So you can represent the solid with the help of octree modeling and the voxels. Voxel is we will discuss all these details in another lecture of solid modeling, after we have covered curves and surfaces. Then we come to the solid, because I don't want to discuss it here to create unnecessary confusion. So this is about the geometric modeling, the basic things. So here is an assignment to give you an overview of the geometric modeling. Now you can make a geometric model, although it is a simple one. It is just giving you an idea of the discussion made in this lecture. You know, make a geometric model in whatever software you want to make, and present its model tree. So you have to see the model tree that is often coming on the left side of your screen, okay, when you are making this thing in a CAD modeling software. Then you draw its wireframe model with three different techniques discussed. Then identify model coordinate, working coordinate, and screen coordinate when you are constructing the cylindrical feature on it, okay. For example, you are constructing this cylindrical feature, and you will have to refer to the its model coordinate, okay. And then name the design features available in the CAD software. So whatever software you, when you are creating this, what kind of design feature you used, or when you are creating this, what kind of design feature you use. Then search for open source CAD software and understand their capabilities. So this is a assignment for you to do it yourself. Thank you.